Contrast bedrock and 16.5 stream channels. Contrast bedrock and alluvial stream channels. Distinguish between two types of alluvial channels. A basic characteristic that distinguishes stream flow from overland flow is that it is confined in a channel. A stream channel can be thought of as an open conduit consisting of the stream bed and banks that act to confine flow except, of course, during floods. Although this is somewhat oversimplified, we can divide stream channels into two basic types. Bedrock channels are channels in which the streams are actively cutting into solid rock. In contrast, when the bed and banks are composed mainly of unconsolidated sediment or alluvium, the channel is called an alluvial channel. Bedrock channels. As the name suggests, bedrock channels are cut into the underlying strata and typically form in the headwaters of river systems where streams have steep slopes. The energetic flow tends to transport coarse particles that actively abrade the bedrock channel. Potholes are often visible evidence of the erosional forces at work. Steep bedrock channels often develop a sequence of steps and pools, relatively flat segments, pools, where alluvium tends to accumulate, and steep segments, steps, where bedrock is exposed. The steep areas contain rapids or, occasionally, waterfalls. The channel pattern exhibited by streams cutting into bedrock is controlled by the underlying geologic structure. Even when flowing over rather uniform bedrock, streams tend to exhibit winding or irregular patterns rather than flowing in straight channels. Anyone who has gone whitewater rafting has observed the steep, winding nature of a stream flowing in a bedrock channel. Alluvial channels. Alluvial channels form in sediment that was previously deposited in the valley. When the valley floor reaches sufficient width, material deposited by the stream can form a floodplain that borders the channel. Because the banks and beds of alluvial channels are composed of unconsolidated sediment, alluvium, they can undergo major changes in shape as material is continually being eroded, transported, and redeposited. The major factors affecting the shapes of these channels are the average size of the sediment being transported, the channel's gradient, and discharge. Alluvial channel patterns reflect a stream's ability to transport its load at a uniform rate while expending the least amount of energy. Thus, the size and type of sediment being carried help determine the nature of the stream channel. Two common types of alluvial channels are meandering channels and braided channels. Meandering channels. Streams that transport much of their load in suspension generally move in sweeping bends called meanders. These streams flow in relatively deep, smooth channels and primarily transport mud, silt and clay, sand, and occasionally fine gravel. The lower Mississippi River exhibits this type of channel. Meandering channels evolve over time as individual bends migrate across the floodplain. Most of the erosion is focused at the outside of the meander, where velocity and turbulence are greatest. In time, the outside bank is undermined, especially during periods of high water. Because the outside of a meander is a zone of active erosion, it is often referred to as a cut bank, figure 16.19. Debris acquired by the stream at the cut bank moves downstream, where the coarser material is generally deposited as point bars on the insides of bends. In this manner, meanders migrate laterally by eroding the outside of the bends and depositing sediment on the inside, moving sideways without appreciably changing their shape. Smart figure 16.19 Formation of cut banks and point bars. By eroding its outer bank and depositing material on the inside of the bend, a stream is able to shift its channel. Tutorial. Meandering rivers. In addition to migrating laterally, the bends in a channel also migrate down the valley. This occurs because erosion is more effective on the downstream, downslope, side of the meander. Sometimes the downstream migration of a meander is slowed when it reaches a more resistant bank material. This allows the next meander upstream to gradually erode the material between the two meanders, as shown in figure 16.20. Eventually, the river may erode through the narrow neck of land, forming a new, shorter channel segment called a cutoff. Because of its shape, the abandoned bend is called an Oxbow Lake.
Hello, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the physical processes that result in the meandering of rivers and streams. So this is what meandering looks like. Look at this crazy loopy path that's being taken by this river here. It goes all the way over here and then back around and then over here and then back around and over this way. I mean, that's just a pretty extraordinary shape. What's the reason for that? Well, let's take a look. Here's a house, and this house is perched on the edge of a fairly precarious looking cliff. That house is sort of set up like this in this diagram down here. You can see the house perched on the edge of the little cliff there in the upper right. Notice that there's a river flowing down below it, and as that river meanders across that valley, the highest velocity water in the river channel shifts from side to side. Let's go ahead and draw two cross sections through the river right there and see what the velocity structure looks like in those two different locations. Okay, first off, in the straight channel, you can see that the maximum velocity is right there in the middle, versus where the channel curves around a bend, the maximum velocity is over towards the edge. It's almost like if you're driving a car around a bend in the road and you're going a little too fast, your body gets pulled towards the outside edge of the curve. Basically, it's all about momentum. And so that ends up being the same thing going on here. You end up having more water energy over on the outside of the curve, and that means that there's less water energy over on the inside of the curve. So if we go back to our main picture here, we'll notice that there's erosion taking place on the outside of the curve, and there's deposition of new sediment on the inside of the curve. We call the outside of the curve the cut bank, and the inside of the curve is the point bar. Here's an actual photo of the real thing in nature. You can see that the river current is coming from the top of the screen down towards the bottom, and as it's flowing along, it ends up curving around the edges. That ends up basically resulting in lower water velocity on the inside of the curve. That means deposition takes place there, so we've highlighted the point bars in red. And then erosion takes place on the outside of the curve, these areas that are highlighted in yellow. If erosion on the outside of the curve ends up lining up with erosion on the outside of another curve, the curve itself can end up pinching off. So you can end up actually cutting off loops of the meanders, and those will become new Oxbow Lakes. So that's shown here in this picture, where you've got erosion basically cutting through a narrow little neck here, and that means that this whole channel ends up being abandoned. That becomes this sort of U-shaped lake called an Oxbow Lake. So where does that leave us with regards to the meanders that we started in the first place? Well, if you let this system run a little while longer, probably what's going to end up happening is erosion on the outside of that curve and erosion on the outside of that curve are going to remove that narrow neck of land. And that's going to mean that the river channel is going to have a shorter path to the sea, therefore a steeper gradient, and its old meander loop is going to be abandoned to become a new Oxbow Lake. Hope you got that. Thanks very much for your attention. This has been another Smart Figure.
Stream channels. Contrast bedrock. In addition to migrating laterally, the bends in a channel also migrate down the valley. This occurs because erosion is more effective on the downstream, downslope, side of the meander. Sometimes the downstream migration of a meander is slowed when it reaches a more resistant bank material. This allows the next meander upstream to gradually erode the material between the two meanders, as shown in figure 16.20. Eventually, the river may erode through the narrow neck of land, forming a new, shorter channel segment called a cutoff. Because of its shape, the abandoned bend is called an Oxbow Lake. Smart Figure 16.20 Formation of an Oxbow Lake. Oxbow Lakes occupy abandoned meanders. Aerial view of an Oxbow Lake created by the Meandering Green River near Bronx, Wyoming. Photo by Michael Collier. Animation. Formation of an Oxbow Lake. Braided channels.
Through time, meanders change shape, causing a neck of a meander to gradually become more narrow. Eventually, the meander is cut off, and this process shortens the stream and creates an Oxbow Lake.
Braided channels. Some streams consist of a complex network of converging and diverging channels that thread their way among numerous islands or gravel bars, figure 16.21. Because these channels have an interwoven appearance, they are called braided channels. Braided channels form where a large portion of a stream's sediment load consists of coarse material, sand and gravel, and the stream has a highly variable discharge. Because the bank material is readily erodible, braided channels are wide and shallow. Figure 16.21 Braided stream. The Nick River is a classic braided stream with multiple channels separated by migrating gravel bars. The Nick is choked with sediment from 4 melting glaciers in the Chugach Mountains north of Anchorage, Alaska. Photo by Michael Collier. One setting in which braided streams form is at the end of glaciers, where there is a large seasonal variation in discharge. During the summer, large amounts of ice-eroded sediment are dumped into the meltwater streams flowing away from the glacier. However, when flow is sluggish, the stream deposits the coarsest material as elongated structures called bars. This process causes the flow to split into several paths around the bars. During the next period of high flow, The laterally shifting channels erode and redeposit much of this coarse sediment,